Okay, so if someone on the Zoom could let me know if you can hear me and if you can see the slides, that would be nice. I assume that means you can hear me. Okay, cool. So let's get started then. There's quite a few of you here. So we're going to be going through how to use Git and GitHub. If you want to, I mean, the sort of workshop is designed, at least in the second half, for you to follow along with your own devices. So if you haven't already got one, probably a good place to start is to create yourselves a GitHub account. That's for free. You can go to github.com and create yourself an account there. You don't need to do this, but that will help. That will help, follow along with some of the examples. At the same time, you also might want to install Visual Studio Code. That's just a text editor that gives you a nice graphical interface to using Git. Again, that's optional, but that's what I'll be using for the example. So if you want to download that, it'll be a little bit easier to follow along. And don't worry, I'll show you how to actually do that and set it up in just a second. Okay, so while some of you are doing that, we'll just have a. Sorry, I didn't realize I can see my screen. Okay, hopefully it didn't die. Okay, at least now it's over there. Hopefully it comes back here. Otherwise, you can all like ruin your necks by looking to the side. Okay, so the point is, I just want to give a brief overview of like what the current experience of the group is. So it seems like the vast majority of people have some introduction to GitHub already, but there's also a sizable chunk of you who'd have no introduction, so that's fine. We'll go through it all. Yeah. And then the majority of you seem to use Windows, so that's what I'll be trying to use for the examples. Although there's a sizable chunk that use Mac or WSL or Linux. For the most part, what I'll show you will be exactly the same between all cases. Okay, so that's just pretty much where we're standing. And so the vast majority of you don't want to use the command line, which is a sensible choice. So the examples that we'll be showing are using the graphical interface using Git. I'll also show at the same time what the command line commands are for those who are interested to see one-on-one how they connect with each other, but we'll be going through examples using the graphical interface. Okay, so firstly, what is Git? So what Git is a version control software. So this is a software that you use to track changes to, in particular, coding projects, but in theory, it works for anything. This is how Overleaf, for example, if you're running your LaTeX projects on Overleaf, behind the scenes, that's using Git to track the changes there as well. So the way that Git works is with these things called commits, which are a snapshot of your entire project at a particular point in history. And you can make multiple of these commits, and that's how you track your changes as you go through the versions of your particular project. So what Git actually stores is not an entire copy of your project at each snapshot or each commit, because that would very quickly blow up in terms of the space. So what Git actually does is stores what's called the diff, which is just the difference between the two files. So it just stores what has been changed. So for that reason, Git is very good for storing things like plain text, which is like most software codes are just stored in plain text. And that's because a very small change to that file will be a very small diff that needs to be stored. At the same time, it means Git is not very great for storing changes to files which are compressed. So that includes things like JPEGs or like Microsoft Word documents or whatever. Those are not like simple plain text documents. They have some kind of compression. And what that means is if you make a very small change to a JPEG, the entire file could actually change a reasonably significant amount. And so while you totally can use Git to do those things, if you're using it to store changes that you're making photos on Photoshop or something like that, your Git repository will get very, very, very fast because those diffs might be very large. So that's why we mostly talk about using Git for things like software projects or overlay for LaTeX and things like that. So why do you want to do this? The main reason that we want version control is so that we can undo the changes that we have done. So that seems fairly obvious. But this is in general like a reasonably a difficult thing to do without some kind of version control software. So if you're not using a version control software, maybe one of the things that you're doing is storing like 100 different folders called versions, and you just save a different version every time you want, and that's okay, but it gets very painful very quickly. And what this allows you to do is backtrace errors. So in particular, if a lot of you have done any coding in the past, I'm sure you've run into this problem where you have a bit of code that you absolutely know worked at some stage in the past and now it doesn't. If you want to figure out why that broke, that's in general a very hard problem to solve, right? If you have a very large, complicated piece of software, it's incredibly difficult to go back and figure out what has changed, particularly when it's just a vague memory that you have that it used to work at one stage in the past. This is a problem that's just almost impossible to solve in the general case. If you're using Git to do version control, this is a trivial problem. You step backwards through your version history until it starts to work again. And then you can look at the last snapshot where it worked, the first snapshot where it didn't work. You can compare the projects at those two stages, and you can see exactly what changed to break that particular code. So that's the real power of using a version control software like Git. The other thing that's from a more practical point of view is Git allows something which is called branching. So what branching does is it allows you to do simultaneous development on your code. So where this comes in really, really useful is if you're working on a piece of code or a project and you have an idea for something that you want to change or some feature that you want to add, but you also need to keep using the old code that you've got. Like maybe you're halfway through implementing a new change and some colleague calls you up and says, hey, I need you to calculate X and Y and Z. But now you can't because you've implemented these changes and they're not finished, so it doesn't work. So the way Git allows you to do this is to have simultaneous branches of your code. So it's essentially making a copy of the code where you can make various changes. And then if you're happy with those changes, you can merge them back into the main branch. If the changes don't work out, you can throw them away. And this way you always have a working version of your code or your project on the main branch, and you can have branches that go off for making changes. And we'll go through this in the examples, which will make a little bit more sense. The other thing that's very useful with Git is it allows remote synchronization. So this is not that flashy anymore now that things like Dropbox and OneDrive and whatever are essentially ubiquitous. But what this allows you to do is synchronize your version of the code with some remote repository. So this allows you to store your code remotely, but it also allows you to share the code very easily with other people. Allowing collaboration. And so one of the comments that I always get is like, well, hang on, what is the difference between Git and GitHub? So Git is the software that we use for the version control. GitHub is simply a website where you can store Git repositories. So GitHub would be this remote website where we can store our code, and we'll have our code there on GitHub, and we can synchronize it with our local version. And again, I'll show you an example of how that works when we get up to it, which will make a little bit more sense too. So those are the good things about Git. There's also sort of a downside, which is that it has a little bit of a steep learning curve. It has a kind of ugly interface that makes it a little bit difficult to learn. And so one of the things is, in order to use Git, I think that stops in a second. In order to use Git, you don't really need to understand what's going on under the hood. You can just sort of learn the things that you're supposed to do. If we have a little bit of an understanding about what's happening under the hood, it really helps immensely to remember, why you've got to do things, why you've got to do them. You'll remember that you have to do them. So that can be very, very helpful. What I would say is the steep learning curve is getting a lot better now as the graphical interface is becoming a little bit easier to use. So it's not as difficult as it used to be. And so that's one of the points of this workshop, is that we'll go through examples together, hopefully, to figure out what's going on. Okay, so let's just go over reasonably quickly the basics of how Git works. And I will sort of preface that in some sense it is a little bit complicated, and so it's okay to not understand everything that's going on here. I just want to give you a brief overview, and then we'll, as we go through the examples, I'm hoping that some of this will make a little bit more sense. But sort of the basic building block of a Git repository or a Git piece of code that you're using is a commit. So this is what we were talking about before. A commit is a snapshot of your entire project. And what the commit says is like what the project is at that time. It also needs to know who made the commit, at what time they made the commit, why they made the commit. We'll talk about these things in a moment. So what's actually contained in one of these commits is the data. And so that's in the form of a diff, as we were talking about before. So it's just the changes compared to the previous version. It contains an author. So you have to tell Git what your name is, for example. So we'll set that up, and it's just who made the commit. They always contain a message. And so in general, this message will be why you make these changes or what these changes do, which helps you know what the version history actually means when you go back to look at it. They also contain parents, and we'll talk about that in just a second. And the final thing is every commit has a unique ID. And that ID, when you look at it, will just be a garbled string of characters. And what that actually is a hash. If you don't know what that means, it doesn't matter, but it's a hash, it's a unique identifier based on the data of the commit itself. And so one of the things that means is that commits are completely immutable. You can't change them at all. Once there's a commit, that's a commit. You can delete them, you can throw them away, and then make a new commit, and that might kind of look like you're changing the commit, but a commit is completely an immutable object. Okay, so if we have one commit, that's not very useful. What's useful is you have multiple commits that's tracking the version control of your software. So often draw those as little nodes on a graph here with an arrow pointing either to the next or the previous commit, depending on the way you think about things. So each one of these will be a new commit in our project. And so this is what I was talking about before when I said the commit contains a link to its parent. So a commit needs to know what its previous commit was so that you can make sense of the diff. So what that means in sort of technical terms is we can think of this as a graph. Again, you don't need to know this, but the technical term is that this is a directed acyclic graph. Directed means it has a particular direction. Acyclic means it can't have any loops. It's kind of the same thing. It's always going in one direction. And the graph, it just means it has these connected nodes. Okay, so that's often how we'll draw these kind of commits, and thinking about it like that and sort of make a little bit more sense in your head. And then so one of the very useful things that we can do with Git is create branches. So we could draw a branch something like this. So that means we'd have our main line of development. And if at this stage I decided, hey, there's some new feature that I'm not sure about, but I want to see if it works, I could branch off and start making commits on this separate branch. If I wanted to, I could merge them back in. So by the way, feel free to jump in and ask questions. I think we have enough time to go through everything a little bit slowly. So if I'm saying something that doesn't make a lot of sense, please just interrupt me. There's one kind of warning. I didn't know exactly where to put this warning, but I think here's a good enough spot. This is something that trips people up a lot now, particularly if you're very used to using things like Dropbox or OneDrive or Overleaf. It does not make any commits or synchronize them with the remote version of your code automatically at all. So if you're working on your code at work, and you want to save the version, you have to tell it to make a commit at this time. It won't do that itself. And that seems, I mean, that might seem obvious to some people, but completely unobvious to others. The reason it does that is because when we're working on a software project, we don't necessarily want to make a commit at every single stage, right? If we have a smaller number of commits, it makes it a lot more easy to step our way back through them. It makes it make a lot more sense. And we don't want to make commits if we're just playing around and wrecking stuff. So this is sort of very natural when you're more used to Git, but if you're first using it, this is something that I think a lot of people actually run into issues where they just kind of forget that it's not being saved automatically because they're so used to using things like Overleaf or OneDrive or Dropbox. Okay, so unfortunately, there's a large amount of terminology, and so I'll try to go through and define some of the important terms for you now. Don't worry too much if you don't remember all of them. At the very least, you'll have access to these slides. You can go back and look at them, but we'll try to understand what they mean. So the commit, we already talked about that. That's the snapshot of the changes in a repository at a particular time. And you'll often hear people talk about a Git graph, and that's just the whole set of commit history that you have in your project. So you can draw a little graph, for example, like this, that hosts the different commits, etc. We talked already about a branch, which is a parallel version of the repository. So we could call this section here a branch. This section here would be a branch. Branch is also a verb, which means we create a new branch. And that's what we're doing here, is branching. I'm sorry, but there's just confusing terminology, but that's how it is. Merge is what we call when we merge the two branches back into one. So you'll hear that word quite a lot. And the other thing that you'll often see is head. And head is just essentially an alias for the latest commit on the current branch that you're sitting on. So this is the head, and you can think of it as the head of the node. So it makes reasonable sense, but there is a lot of terminology to get your head around. Okay, I think I already used this word a couple of times without really explaining it, but a remote is a version or a copy of your whole repository on some remote server. So that remote server will typically be GitHub, but it could be any other number of websites or any other number of servers. Sometimes people also use the word upstream, and that's talking about changes that are made up in the remote, for example. So that would look something like this, right? So we have an entire copy of our Git history, our entire version control of our entire project locally and in some remote, which usually is GitHub. And we can keep these things synchronized or not, but we usually want to keep these things synchronized. Okay, so the next word is clone, and clone means making a local copy of a remote repository. So if you have a repository, or I have a repository somewhere on GitHub, for example, and I want to grab a copy of that, that's called making a clone of that repository. A related word that you'll hear is fork. This is essentially the same thing. This is kind of a rough definition, but essentially a fork is a copy of a repository that you do up in a remote somewhere. So we're actually going to do this in a moment. I have a repository on GitHub. What I'm going to make you all do is make your own fork of that repository, which just means making a copy or a clone of it onto your own GitHub account. And then you will clone your copy of that repository down onto your local computer so that you can play around with it. The word is pull. We'll hear this a lot. And what pull means is we are pulling the changes from a remote repository down onto our local version of the repository. Sometimes you might hear the word fetch, which means that we are checking what the changes on the remote repository is without actually merging them into ours. So that's something that doesn't make a whole lot of sense anymore. There's not a huge reason that we would need to do that very often now. But in the past, when internet connections were extremely slow, it was a lot easier. Like it was a lot more beneficial to like just check what has changed without having to actually download all of the changes. Roughly speaking, that's the main reason for something like that. Push is the opposite of pull. So a push is where we've got changes in our local version and we want to push them up to the remote repository. And then a couple of other words. Checkout means to switch between branches. So if I'm sitting on this branch here, for example, and I want to jump over to this branch, that's called check out. So I'm checking out the other branch. You can also use checkout to jump to other nodes that are not necessarily whole other branches. So if you're sitting here at head and you want to check out a version of the software that was 3 commits ago, you use checkout to do that. And then the final one, I think I already defined this, but the commit ID, sometimes this is also called the commit hash, and that's the unique identifier for every one of the commits in the repository. Okay, so that was a hell of a lot of terminology. If there's any questions, please ask me about them now or let that sort of sink in for a second. Otherwise, what we will do in just a moment is move on to the interactive part of the workshop where you're going to do essentially all of these things. And if there are questions online, feel free to drop them in the chat too. Yep.
Sorry to be
No.
but does it actually store difference in information, or does it store, like, if we were able to delete one of the earlier commits, would it actually affect the later commits?
If you simply deleted one of the earlier commits, you would break the graph, it wouldn't work. What you can do instead is a way to it's called rebasing, that you can essentially remove one of the nodes, but it will have to make a new commit to do that. So yeah, it really only stores the diff. And that's really important when you have large, I mean, to be honest, I don't know exactly how it works on GitHub, but the amount of data that it's storing is very small. It's just, if otherwise, if you had a huge project, it would easily the size of the Git commits would become combinatorially larger as you went along. Yeah, but a good point is here, some of the things I'm talking about are kind of the abstract way to think about it rather than what's actually happening in the code, what's actually happening in the Git coders. So who cares about that? But this is the way it works. Okay, so I know I was rushing through that a little bit, but I think it will become a lot more clear as we go through the actual examples. So I'll try and go through the examples themselves a little bit more slowly. So the first thing to do to make this easy is to try and install Visual Studio Code. If you don't have that already, this is not strictly speaking necessary. You could use a different software if you wanted to, but the examples that I have will be in Visual Studio Code. It's a very ubiquitous text editor that's designed for writing and developing code. So that's one that I would typically recommend that you use. Just one quick warning for those of you who haven't installed it yet. Microsoft is really, really great at naming things. It's important to keep in mind Visual Studio Code and Visual Studio are two completely different things. We don't want to install Visual Studio. That's something entirely different. We want to install Visual Studio Code. Visual Studio Code is just a text editor. It's completely free, and I'll give you a couple of minutes to install that. And if anyone has any trouble, feel free to ask me, and I'll give you a hand with that as well. And at the same time, if you haven't made a GitHub account for yourself, that will also help with going through some of the examples. So you can create a GitHub account for yourself. That's also completely free. Okay, and as you do that, the first thing that we're going to need once we have a text editor or something like Visual Studio Code installed is to also have Git. That software is its own program, so we need to have that installed as well. If you are using a Mac and you have ever used Xcode or any kind of coding on your Mac at all, you almost certainly already have it installed. It comes with Xcode, so you probably don't need to do anything. If you're on Windows, you will need to install it yourself. And the easiest way to do that is to do that on Visual Studio. So in Visual Studio, and I think I can swap. Hopefully they can still see my screen. In Visual Studio, here's my Visual Studio window here. You have a bunch of buttons on the left-hand side. One of these, which looks like a little chunk of a Git graph, is the source control button. And if you click the source control button and it says open folder clone repository, that means you already have Git installed. If you click on that button and instead it says download Git for Windows, that means you don't have Git installed, and the easiest way to install it is to click that button. Installing that will take a minute or so. It's not an enormous software. There's just one warning: as you go to do that, you will get a window pop up at some stage that says choose the default editor for Git. And because the people who wrote Git are like Unix people from the 80s, the default text editor that's used with Git is Vim. And that's still the default that's checked here. If that's what you want, fine, but probably you don't. So make sure you choose use Visual Studio Code. For those who don't know what Vim is, don't worry about it. You don't want to use it. You want to use Visual Studio Code or Notepad++ or something else. But if you're using Visual Studio Code, you may as well use Visual Studio Code. So I think I will give a minute or so for that, and I'll kind of wander around and check where people are up to as well. Yeah, I don't know what. It doesn't matter. Oh, yeah. So I'll just. Yeah, so there's a bunch of like questions that the Git installer will ask you. Almost all of them is completely fine to just use the default for whatever was already selected. The one difference is this default text editor gets by Git. And if there are people who want to use the PCs in the room, you absolutely can, but unfortunately the school doesn't like installing any software on them anymore, so you have to use the UQ digital workspace, open a student terminal, and on that student terminal you do have VS Code installed, and I assume they at least allow you to install Git. If not, they'll get an angry email from me. So while you're doing that, the one thing as well I'll point out is that if you're averse to using VS Code for whatever reason, there are a bunch of other graphical interfaces to Git that are reasonably common. I think GitHub itself has one called GitHub Desktop. I'm not sure if they keep that being updated, but that's one a lot of people use. Another one that's very common is I think Git Kraken. They will both work very, very similar to what I'm going to show you. Exactly the places of the buttons, of course, will be a little bit different between the different software, but the general gist of it will be the same between all of them. So if you want to use any of those. Okay, so if there's anyone still stuck, you can put your hand up and Ash will come around and help you. Otherwise, I think we can start moving on to some of the examples. So before we get right into the examples, there's one more thing that you'll find a little bit helpful. This is, again, completely optional, but there's a bunch of plugins for VS Code that make life a little bit easier. The one I completely recommend is called Git Graph. You install the plugins in VS Code by clicking this little button that looks like 4 squares, and you type Git, and Git Graph will usually be the first one that comes up. If not, type Git Graph and it will come up. It installs in a couple of seconds. And what this does is give you a nice interface to see the graph structure of your Git repository. So of course, you don't have a repository yet, you'll see nothing there, but when we have a repository, that makes life a little bit easier. That's just a nice thing to look at. One of the reasons this is actually quite nice is it gives you this little button here, which is a settings button, and that allows you to access some of the settings inside Git, so you can change them without having to incant spells on the command line, which makes life a little bit easier as well. Yep. It's not what now? Oh, yes. Yeah. If you really want to, you can do Git lens too. Okay, so the one thing I'll just point out too, for those of us who really like to use the command line, instead of using a plugin like GitGraph or GitLens or one of the others to see the graphical structure of our Git repository, you can also do that on the command line. The exact same repository then looks like this. If that's something that you're really keen on, then you can do that as well, but most people prefer to just use one of the plugins. Okay, so if people are ready, what we will do now is actually start the workshop tasks. So to do that, what you want to do is head over to this Git repository. So I'll show you that at the same time. So that is this repository here. Don't worry too much about what's in the repository. This is just something that we can play around with to get working. What's actually in here is sort of instructions for using Git on the command line. If you're interested in that, the point is it's just a random repository that we can play around with. One other thing that it has, though, is a link to the current slides, so you can use this to get access to those slides as well after today. Okay, so the URL is github.com benroberts999/git-workshop. Okay, so what we will be doing when we get to it is we will be making a fork of this repository, and that means making your own personal copy of that repository onto your GitHub account. Then we're going to clone that repository down onto your local PC. So the reason we do that in 2 steps rather than just cloning my version is if you clone my version, you won't easily be able to push any of your changes up, right? That's my version of the code. You don't have access to make changes directly to it. You can submit a pull request. We might come to that later, but that's not going to work with all of you. So what you want to do is make your own copy, clone that down so you can make the changes. Then what we'll do is we'll make some changes on our local version and then push those changes up to the GitHub, and you'll see them synchronize. Then we'll make some changes on the GitHub version and pull those down. So that's sort of simulating if somebody else has made changes to the code and we want to pull those changes down. Then we'll have a quick play around with branches. So we'll make a new branch, make some commits on the new branch, swap between the branches, and then merge those branches back into the main branch. Okay, so we'll go through each one of those steps a little bit more slowly. So let me know if people are still struggling to find the repository, or if I think I lost the URL already. If you haven't found it, please let us know. Otherwise, the first step is to fork the repository. And you do that by clicking the little fork button at the top here on that repository's webpage. And what that will do is make a copy of this repository in your GitHub account. Okay, so when you've done that, you'll be able to go to your GitHub account and you should see a copy of this repository that's available on your GitHub account. And then what we can do is clone that version. So if you're using the command line, the way you do that is from the command line, you write git clone and blah, 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 the address for the Git repository. The way that we will be doing that is using the graphical interface, which somewhere. It's okay. So we will be clicking this clone repository button. You get that by clicking on the source control part in VS Code, clone repository, and it will ask you for either the URL, or if you're signed into GitHub, it will ask you for your GitHub. You can log into GitHub, it'll ask you for your GitHub username and password, and with that you can choose from a drop-down list of your repositories. There it is. Okay, so that will look something like this. You can either type the whole thing here, so it'll be HTTPS and then the entire name for your GitHub repository, or you click clone from GitHub and it will first ask you to sign in using a pop-up, and then it'll let you choose your repository from a drop-down list. So clone repository. Yeah, and if you hit clone from GitHub, then it will ask you to log in to GitHub. And it will take you here and then log in. And then you have to authorize, that means you're giving VS Code authorization to access your GitHub account. And then you click, yeah, open in VS Code, and then it will open VS Code again. Now, if you click the same button, it will give you a drop down of all of your GitHub repositories. And I assume this is your only one, which is why that's there like that. And now, okay, so that brings me to the next point. When you do this, you will be asked where on your computer to store this GitHub repository. So the GitHub repository, when you clone it down to your PC, it will live in a particular folder, a particular directory on your local computer. Do not put this inside a Dropbox or a OneDrive folder. The reason for that is that Git works by storing a bunch of configuration files in a hidden folder inside the Git repository. And Git wants to be the only thing that accesses and changes that file. So there'll be one of those files on your local PC, one of those files on the remote. And if you're using something like a OneDrive or Dropbox, OneDrive will try to synchronize changes with this folder as well as Git. And every now and then that can cause big problems like corrupting Git repository. Yeah, so try not to do that. Unfortunately, on Windows, it's getting harder and harder and harder not to save something in bloody OneDrive, but try to put it somewhere that's not inside a OneDrive folder. Okay, we'll wander around a little bit now. Don't need this year, as we press it down, we have more and more. Yeah. It's not really an issue. also use Git. So it's not like yes, as long as you, well, if you make changes from another or so then it's but I would still try to go one level higher. So it's usually outside. But yeah. Yeah, so your documents is seen as one right by default now. So just yeah, exactly. And so it's like 90% of the time will be fine. So yeah, so look, that's another reason why it's good to sync. Yeah. Yeah, that sounds like a fun investing. You put it inside yeah, and then okay. Yeah.
It's a lot easier.
So if you're already tracking the file, I'll come to get you tomorrow. What I would try is go back to the cartoon, delete everything and one version. Yeah, I'll try to figure that out. Okay, so I think most people have got up to that. So please let me or Ash know if not, but otherwise we'll barrel on forwards. So just very quickly, if we don't want to clone another repository, say we had some files on our own computer that we wanted to turn into a Git repository, that's the other button that's there in the source control, which if you're in a new file, it will say initialize repository. What that will do is create a Git repository here, and then you can push that up to GitHub. So this is mostly for your reference if you want to come back to that later on. Okay, so what we are about to do is make some changes to this file and push them up. But if you'll remember a little while ago, I said every one of our commits in Git has to have the name of the person who made that commit. And for some reason, Git doesn't automatically figure out who you are, so you have to tell it. So that's what we are going to do using Git graph. What we need to do is just tell it what our name and our email address is. That's information that Git requires. There's no law saying that these need to be your actual name or your actual email address. It doesn't need to be the same email address that you use for your GitHub account, for example. It usually makes sense if they are the same, but there's no reason they need to be. So you can make anything up here that you want. But the way you would do this if you are using the command line is to type these commands at the bottom. If you're not using the command line, then we have to use some graphical interface in Git Lens. In Git Graph. The way you do that is by clicking the source control button, then clicking the Git Graph button, which is this tiny little one here, and then clicking this settings button here, which will bring up this window, and then you need to edit and add your name and email address. If anyone has trouble finding that, you can let one of us know. VS Code doesn't come, as far as I'm aware, with a way of doing this without using an extension. There might be, otherwise you can use the git config. If you have one of these like AI extensions on VS Code, you can just ask the AI extension to do it for you, and it actually does. I tried that out the other day. That seems to work reasonably well as well. If you don't want to do that, then these are your two best options.
Access if graph.
Mhm. So you click the source control button, and then this tiny little thing here is the button for Git graph.
Oh, yeah.
If you don't see it, you just need to drag this thing until it appears. Yeah, or click the three dots.
So we have to do that for every.
I don't know. If you use the command line, this -- global thing will make it a global setting for all of your Git. To be honest with you, that's the way I did it. I don't actually know whether you do them in this repository settings, whether that's global or only for local. You'll have to try it and see. There may well be a way to do that globally as well.
And the username is GitHub.
No, so when it says user.name, that just means the name of the user, and you can put whatever you want. So what's quite common, some people do this, for example, is they'll say Ben in brackets at work, Ben in brackets MacBook. If you want to know where you've made the commits from, I usually just put my name, whatever. But yeah, but in theory, it could be anything. There's no rules whatsoever that this means something. Why this is important is if in like 3 or 4 years' time, there's some problem with your code and it happened in this commit, and you're working in a big team, for example, it's useful to know who made certain commits, but if it's for your own project, of course, it really doesn't matter.
Using and using like sometimes people using
Mhm.
nowadays.
Yes.
What exactly are you saying about something about saving? Keeping track.
Oh, so the idea of having a name associated with each commit is just so you know who made each commit. So if it's your own project, then that's probably going to have been you. But if you're working in a team, you're like Joe made this, Alice made this, et cetera, et cetera. So what some people do is in their name, they'll also add, where they were. So if you're making changes from your work PC rather than your laptop, you might want to put that in your name too. I don't do that. I don't necessarily think it will benefit to that, but that's I've seen that quite a lot.
So is that what you're talking about? Do we have to use this for each commit? But
No. So this is at the very least project-wide setting. So for one Git project, one Git repository, you will only need to do this once. If you're using the command line, you can make it global, so you only need to do it once for your entire Git installation. I don't know whether or not this is a global setting or a local setting when you do it through the graphical interface. Just because I haven't tried that, but there probably is a way to make it global, but you can Google that. Didn't figure it out. But yeah, no, we only need to do this once for a project, the very most. You don't need to do it individually for every commit.
if I download this currently from another device,
Mhm.
and I download this repository.
Yep.
And if I make changes to it and I name myself differently,
Mhm.
that be recorded with that different.
Yeah, yeah. So if you have one version of your repository on your work PC and you call yourself BM Roberts, and then you have one version on your home PC and you call yourself Ben Roberts or whatever, then yeah, it'll store those. And that some people find it helpful to know where they've made the commits. Yeah. Yep. Mhm.
Does that mean when you branch, you currently have two versions of?
Yeah.
And then when you say merge,
Mhm.
what happens to so you work for this
Yeah.
branch?
Mhm.
You make some changes to both of them.
Yep.
You merge the one that was branched.
Yep.
What happens to the one that was?
Yeah, I'll just go back to, I think it's a bit easier to start. I didn't merge those ones. Yeah, here.
What happens to that one? When you
What happens to this one is it just stays there unless you delete it. So if you, so the question was, if you make a branch, we'll come up to branches in a moment, but somebody asked the question, so we'll go through it. If you make a branch and then you merge your two branches together again, what happens to those other commits from the other branches? And the answer is they just stay there on your local PC. They're part of your version history. And so they stay there unless you do anything weird to get rid of them. So you will have both of these. And if in the future you want to jump back to the project at some stage as it was on one of these random branches, you just can. So all of that stays exactly how it looks here. Hopefully that's sort of clear, but it will make a little bit more sense. We're going to go through an example of merging in a moment. Is it a question? Yes. So yeah, we'll come to conflicts in a minute too. So when you try to merge the branches, the best case scenario is your two changes are compatible with each other and Git will just work out how to merge them. Unfortunately, what often happens is you have two changes to the same piece of code, for example, and Git doesn't know, then you have to tell it itself, and that's a constant headache for everyone. But we'll come to that in a moment. Okay, so please let me or Ash know if you're still having trouble getting your username set up. Otherwise, we will now start to actually make a couple of commits on our repository. So what I want you to do in this part of the workshop is just make some random changes in that repository that you cloned. So open up one of the files, add a new file, type some random words. It really doesn't matter what you do, just make some changes. So for example, I should have done this at the same time. That's okay. Okay, so in this example, I made some changes to the workshop tasks.md file. And what happens if you've made those changes, if you click on the little source control button here, is you'll see that that file is listed as a change under the changes heading. So what this is another thing that can be a little bit confusing to people the first time they start using Git is this kind of two-step process that it takes to commit your changes. So I think actually in VS Code, if you just hit the commit button, it will do both of those steps for you. So for the most part, you don't really need to worry about it. But there's actually two steps to saving the changes that you've made. The first step is called staging. And that's essentially when you're deciding which changes you want to include in your commit. Then once you've staged some changes, and you stage the changes by clicking the little plus button here. And when you do that, my interactive version isn't working, but when you do that, it will move up into another heading that's called staged. And then once you've got some staged changes, you can hit the commit button and that will create a commit from those staged changes. Now that seems like a really weird thing to have to do. But the reason it's like that is because if you're have a reasonably large project, it's very often the case that you don't want all the changes that you made all over the place to be wrapped up into a single commit. So it gives you the option to just commit individual files. And in fact, I'm not going to show you, in fact, I don't even know how to do it on the graphical version, but it's even possible to save and commit changes that are just to part of a file, so you don't need to commit the whole file. And that's particularly useful, for example, if you're tracking down some bug, and in order to find the bug, you put a bunch of debugging print statements everywhere. You don't want to have to delete those all just to do the commit. So what you can do very easily with Git, well, not that easy, but you can do with Git is just commit the part of the change that you want, and then just throw away, once you've committed that change, throw away all the other changes to the file. Okay, but putting all that aside, for the most part, you can also just hit the commit button and VS Code will ask you, do you want to stage all and commit all changes, and it will let you do that. When you hit that commit button, a window will pop up asking you for a commit message, or you can type the commit message yourself earlier in this little box here. So before we mentioned, every single commit has to have not just your name and your email address, but also a commit message. And this message is something that, in theory, should be descriptive about what the change that you've done actually does. So in theory, you want to have very descriptive commit messages so that when you're going back through your version history, you can understand what they mean. Obviously, in this case, we're just making random changes, so you can make whatever random commit message you want. If people are interested, there are a wide variety of people who have very strong and conflicting opinions on how you should write a good commit message. One of them, for example, is in this link, but that's a bit beyond what we need to discuss for now. Yeah, and if people are interested, the command line options for staging and committing files are down the bottom as well. Okay, so if your commit button is gray, that probably means you don't have any changes to commit. And that will be either because you haven't made those changes yet or because you haven't saved the file. Is my guess. That might also happen if you haven't initialized a Git repository yet, but that should hopefully not be the case. Yeah.
Commit.
Mm-hmm.
Yeah.
So if you, that's a good question. So if you forget to write the commit message in this little window before you hit commit, it will open up a text window for you to write the commit message in. If you forgot to not use Vim but VS Code when you were setting up Git, it'll be a Vim window and you'll be stuck there for the rest of your life. If you did manage to change it to VS Code, it will just be a regular text box that you need to type your message in. And all you do is type your message, save it, and close that file, and that will continue with the rest of it.
Is there any helpful tips for how to translate commit messages? Is there a helpful way to kind of write some flags?
There is a, yeah, so usually the commit message will be like there should be like this commit, you don't need to rate it because everyone knows it's a commit, but like fixes bug X or adds feature Y, for example. Again, I think that there's a lot of very strong opinions on the right and wrong way to do them. Everyone disagrees, and there's some discussion about it at this web page here. But generally, the commit should say in pretty briefly what this commit does, and you can actually write very long commit messages. The format for them is that it's generally a short message, then you leave a blank line, and you can write a very long thing afterwards. But like I can go back, I think I had a very bad example a moment ago when I was showing you this graph, but here are some like commit messages from some random repository that I wrote. None of them are particularly good, but you can see it says fixes, some introduces new issues. makes brigade, etc. Yep.
Change.
Yeah, we'll get to that. We're not up to that yet.
Then I've got
Yep.
understanding the difference between stage.
Right. So the difference between stage and commit is what stage does is say which changes I want to commit, and then commit actually commits them. So stage doesn't do anything permanently at all. It just says which ones I want to include in my commit. Now, like 99% of the time, you just want to include all your changes in your commit. But sometimes you may have changed two different files, and for the benefit of your future self, you want them to be two different commits because they might be completely unrelated. So then you can stage one of those, commit that one, then stage the other, commit that one, and then you'll have two different commit messages.
When you're working with two or more files.
In the simplest case, yes, it's when you're working with two or more files. It is actually also the case that you can break the changes that you've made to a single file into multiple commits, but that's more complicated and beyond what we want to get into.
Going by the simple example.
In the simple example, if there's only one file to change and we've only made one change to it, then there's really no reason to separate stage and commit, but that's just the way Git works.
If you have two files.
If you have two files,
You can press commit. You doesn't commit both of them.
if yeah, by default, if you just hit commit on VS Code, it will commit both of them at the same time. If you do that on the command line, nothing will happen. That forces you to stage them. It's just when you use VS Code, it will automatically, in fact, I think a little window will come up asking if you're sure, but it will stage everything and then commit everything at the same time by default.
But if you only stage one of them.
If you only stage one of them, it will only commit the one that you staged. Yeah. Okay, so just because everything wasn't quite as confusing enough as it was, I want to take a little interlude now to tell you about something which is called a .gitignore file. So if you have cloned the current repository, there will already be a .gitignore file included in there. And as a general rule, you do want to include a .gitignore file probably with every one of your projects. And the reason for this is that you don't typically want to track every single file that you might have in your repository. So for example, if you have a LaTeX project that you're tracking, you don't want to track the files like the log and the awks and the out. And you also probably don't want to track the changes to the PDF. So I should add the PDF to that as well. So what you can do is add a .gitignore file and list all the files that you want Git to ignore. That just means Git will not track them, so that they're not tracked every time. That will just make it a little bit easier for you to say, hey, stage everything, commit everything, without having to say, oh, except for these random files that I don't want to commit. Another one that's very, very common for people who use Mac. Macs very much love creating this random file called .dsstore. I don't know what it does. Some hidden Mac thing for figuring out Mac stuff. You generally don't want to track that as part of it. It's not going to cause any issues if you do, but you don't really want to track that as part of your project. So what you do in this .gitignore is list all the files that you want to exclude. There's another way to generate a .gitignore file, which is very common, which I would typically actually recommend, and that's to do it in the opposite way. And so instead of listing all the files that you want Git to ignore, I tell it to ignore absolutely everything, which is what this first line says here. And then I list the files that I want it to not ignore. So for example, if it's a C++ project, you don't want it to ignore the C++ files. So the example that I think comes with the repository that I've asked you to clone looks like this. And that way you can just add the types of files that you want Git to track or that you don't want it to ignore. Both of these methods are very common. They both work. Again, it's not strictly required. It does just make your life a little bit easier, particularly if you're generating a lot of files. So one thing in particular, like if you have a very large software project, you generally don't want to store using Git huge output data files. You don't want to store huge log output files, and you don't want to store very large compiled executables using Git. That's just a waste of of space, and it will make the synchronization very slow. Okay, so that's just a little aside. You can copy and paste these examples if you want to for your own projects. But that's just an important thing to keep in mind. Okay, so hopefully everyone has managed to make and commit some changes to their repositories. Let me or Ash know if you haven't. But now what we want to do is push those changes up to GitHub. So the first thing to just tell you about is the concept of a remote. So in a Git repository, there are things called remotes, which are just a link to the remote version that you want to synchronize everything to. Now, this is not something that you ever need to think about. If you did what we did and cloned something from GitHub, then that will already be all set up for you. If you didn't clone from GitHub and if you just created a Git repository on your own device, then of course you need to tell Git where that remote repository is that you want to submit that stuff to. So you can do that by going git and remote and add remote, and you add the URL for the remote that you want to push to. We won't need to do that because we've cloned from GitHub already, but I'll mostly just leave this here as a reference for you to come back to if that's ever something that you need to do in the future. Okay, so what we want to do now is push those changes up to GitHub. So if you did everything successfully so far, when you look at the source control button, it should now say sync changes. And now we have like multiple options for how to synchronize the changes. We can click this big sync changes button. If you look down in the bottom left, you'll probably also see this little symbol here. What that means is that we have 0 upstream changes to pull down, but 1 downstream change that we can push up. And if you push that button, which you can click, that will also synchronize the changes. And if you like going through long menus, you can also click 3 little dots and click the push button. That will also push your changes up onto GitHub. Okay, so give that a go, pushing the button. If any of you has a little error message that comes up when you do that, it means something went wrong in one of the previous steps, in which case either Ash or I will give you a hand figuring that out. And if you really want to, on the command line, the way you do that is git push and then the name of the remote and the branch name that you want to push up, which is typically origin is the upstream branch, and main is the typical name for the branch that you're currently on.
Probably just not part of it.
Okay, so if that has worked for you, what you should be able to do now is to jump over back to that GitHub web page. Okay, so if that push has worked for you, what you should be able to do is jump back over to the GitHub web page. This time you don't want to be looking at my version of the repository, but yours. So this should say your username /Git Workshop. And if you refresh the page, you should be able to see here whatever changes that you made on your local PC, and they will be up there on GitHub. So magic. Okay, so hopefully that has worked for people. We still have plenty of time, so if not, let me know and we can come and make sure that that's working. A common error that people will have at this stage or the previous stage is about logging in to your GitHub account. Because of course, in order to publish those changes to that GitHub account, you need to be authorized to do that. If you're using the command line, this is a bit of a pain. You have to set up SSH keys, blah, blah, blah. Don't worry about that for now. If you're using VS Code or GitHub Desktop or one of these graphical interfaces, that should allow you to log in through itself. And so the first time you push or pull, if you're not already logged in, it should pop up with a little window asking you to log in. And that will connect to GitHub. You have to give it authorization access. Hopefully that happened recently, and if that didn't, then that's probably likely the issue if anyone's having issues at this stage. But if you are, just let us know before we continue.
I think that imagine I got the finger into the line. Oh, it's this section.
It probably means it's finished.
Right.
Yeah.
It says something. Yeah.
Yeah. Okay, so there's one question that's good, which is every now and then VS Code will come up with a little pop-up asking you a question, and that question is, would you like VS Code to periodically run fetch? It's a good idea just to click yes. What that means is, would you like VS Code to periodically check GitHub if there are any changes in the online version? So that's a good idea to click yes to that, just so that you know if there are any changes upstream. If you click no, it's not the end of the world. It just means you'll have to refresh things or wait a bit longer to actually see those changes on your personal piece. Oh, yeah, I think it's the default. Oh, it's working. Yeah, yeah, I'm yes.
I've never seen that.
Yeah, the one.
And then what eventually was from that audience. Then you can make changes to that branch. Okay, so it does seem like most people have managed to do that by a couple of internet issues, but if you're still having a little bit of trouble, or if you haven't been able to see the changes up on the GitHub, please let us know. But even if that bit didn't work, you'll still be able to go on with the next part of our example. So maybe we'll just continue with that in any case. So what we want to do now is make a change on the GitHub webpage itself, and we will pull those changes down into our repository. So the way you can do that on GitHub is on some of these files, you'll see a little pen icon that will allow you to change the file directly on GitHub. Once we've changed a file on GitHub, we will also need to make a commit, and you do that by clicking the commit changes button that will show up. That will ask you to enter a commit message. It's all very similar to doing it on VS Code, but now we're doing it on GitHub itself. Now, of course, in real life, you're unlikely to make large changes to a code on GitHub itself. The point of doing this is to simulate the situation where we have some changes in the upstream repository, maybe that a collaborator made, or maybe that we made on a different computer that's synchronized to GitHub, and we want to pull those changes down. So head over to the GitHub repository, again, the version that you have on your GitHub account, and make some random change to one of the files, commit those changes, and then in a second, we will try to pull those changes back down. Yeah, the reason for that is we'll actually pull and solution at the same time. So if there were changes on there, but yeah. Yeah, see, or the a lot of people have this problem. I think the Wi-Fi is so they're just thinking they're all fine. It's by default origin. So you can usually just write it actually. Figure out the rest. So just hit enter. If it doesn't work. Yeah, the problem is sometimes just password on. It doesn't need SSH. Oh. Come back. But I think it's just an internet problem. Yep.
Yep. like change on
Yes.
this.
Mhm.
That's commit.
Yep.
And let you-
No, it will just make the changes in your online repository. Yep.
What's that?
Yep, that's 100% what you want to do. Yep, exactly. Yeah, yeah, that's
I'm
okay.
just missing things.
Mm.
So I downloaded this.
Yep.
And then
Yeah, so what you want to do, instead of initialize a repository, let's open a new window. And then when you click this, it won't say initialize repository, it will say clone, download Git for Windows.
Okay.
So you want to download Git for Windows. And then the one thing to be aware of is you just install it in the Git thing.
Yeah.
When it asks you to set up default text editor, make sure to choose VS Code rather than Vim, and let's see what to use.
okay. Right.
Yep.
Thank you.
This is the commit message.
Yep.
For the description.
Okay, so that's a good question that somebody asked. When you go to make a commit on GitHub, and it might actually be the same on VS Code, I don't remember, but it gives you two kind of text boxes for the commit message. One it calls commit message, one it calls description. From the point of Git, there's not actually different things. The commit message is just the header, essentially, of the message. And so in general, for the commit message, the short one at the top, you want to have something short and descriptive that you can easily see what this commit has done. And then in the description, you can write as much long stuff as you want. And it's just a way of separating the short message from the long message. For 90% of small commits, you don't need a long message at all. That's only if you're like describing the bug that you fixed or describing how you fixed it or something like that. Most of the time you don't need one. Great. That's just going to keep such a bad.
This
Well, it's remote from the point of view of your local scene.
Did you say
So yeah, you can call it that. Yeah. Yeah, essentially, yes.
Wait, no, actually.
Yeah. But 99% of the time, remote means GitHub. So yeah, that's exactly. So that's. Okay, so how's most people going with that? Please again, let us know if you're having any issues making those changes on GitHub. So hopefully you managed to make those changes on GitHub, commit them there. So now what we have is some changes that are on the GitHub, which is like the remote version of our repository. And we don't have those changes unless you were jumping ahead on our local version of the repository. So what we now want to do is pull those changes down onto our GitHub repository. So what you will see now, if you click the source control button, and sorry, I cut the source control button itself off on the screenshot here, but this is still in the source control button. You will hopefully see a little thing that says sync changes with a 1 and an arrow pointing down. That means VS Code knows that you have one change up in the cloud that you haven't pulled down. If it doesn't say that, it's because VS Code hasn't noticed that there is a change upstream, right? It wasn't automatically checking. And if it hasn't checked, what you can do is click the 3 little buttons and click the fetch button. And what that will do is fetch those changes. Once you've done that, you should see this sync changes button. And once you see that sync changes button, that is the same as doing a pull. So if you click that, it will synchronize. Alternatively, you can click the 3 little dots and then click pull, and that will pull the changes from the GitHub down to our local version of the repository. If that works, then you should be able to see those changes that you made on GitHub on your local version. Now, this is a part where it's possible that some of you will run into an issue, particularly if you made some changes on your local version and didn't push them up successfully before you made changes on the upstream version that you tried to pull down. If that's the case, you might have now conflicting changes and you'll get an error message saying can't merge, there's a conflict. If that's the case, let us know, but hopefully, hopefully if both the steps work for you, then this will be fine.
Okay, so I installed it. And I already forced it. I've already forced it. Yep. So I've got it there.
And now you want to clone. So again, go back to so the reason it's us telling you this is because you're in a repository, you're in a folder. So I don't know what this is. This is the project or something.
Yeah.
So what we want to do is go to this and open the other window. To this.
No, I just
Oh, you
did
did.
it.
Okay.
What's going down?
Right. So what you want to do is set a new window. So this is just a blank window with nothing there. Now when we click this, it will say clone repository. Clone repository, and you can either put the whole URL, or if you go on GitHub, it will sign you into GitHub, and then you'll be signed into GitHub from your VS Code. And then it will have a drop-down list of all your GitHub repositories and the one that you want.
Oh my God, so that's funny. And it's neither of which is
I'm completely fine with it. I think
I normally
you did it once.
Yeah.
Start and then it's fine.
Okay, so just to reiterate what we have done now, we cloned this repository, which means we grabbed a copy of it down onto our local computers. We made some changes on that repository locally. We committed them. We pushed them up to GitHub, and then we saw that they were on the GitHub webpage, hopefully. Then we made some changes independently on the GitHub webpage, committed them on GitHub, and then pulled them down, synchronizing those changes into our local repository. And hopefully now you can see both of those changes that you have in your local version of the repository. So that simulates making some changes and committing them, and then someone else making some changes somewhere else and us pulling them down. So hopefully that worked. If it doesn't, either we can kind of help you now, or I'll be sticking around a little bit afterwards to help you with that too. What we will look at now is the final thing, which is branches and creating a new branch. And this is one of the things about Git that's really, really powerful and makes it extremely useful for actually working on projects. And even if you had a bit of trouble with the previous couple of steps, this will still work fine. So what we want to do now in our local version of the repository is create a new branch. So the way that you do that in VS Code, for example, through the source control window, we can click on the three little dots and go to branch and create branch. By default, that will branch off from whichever branch we're currently on. Probably you only have one branch, so that's the only option. If you have like 10 different branches already, you could choose create branch from and branch off from a different branch, but normally you want to branch from the branch that you're currently sitting on. When you do that, you'll have to give the new branch a name. You can call it test branch or add feature or whatever you want to have for your other branch. And when you do that, you will see in your source control button that there'll be either a synchronize changes or a publish to GitHub or something like that button, which will synchronize this branch up to GitHub. You can do that if you want. You don't need to. We're going to make these changes locally, so that should just be fine. So I'll give you a couple of minutes to set up that new branch. But what we're going to be doing is making some commits on this new branch, swapping back to the old branch, seeing that the commits aren't there, going back to the new branch, seeing that it's still there. And then what we will eventually do is merge these two branches back together into our main branch. Okay, so the question was, what does publish branch mean as opposed to like push? And essentially it just means when we say push, we mean we're like synchronizing changes up into a branch that already exists on the GitHub, whereas publish branch is like putting a new branch that doesn't yet exist on GitHub. It's the same as push. You can think of it as the same as push. It's just putting whatever new branch that we've created locally and putting that up, synchronizing that as well onto the GitHub repository.
Branch in the local,
Mhm.
and you just have to commit in the
Yep.
By publish, then you'll create the
And
branch.
it'll create the branch on the GitHub too, exactly. Okay, so please let me or Ash know if you haven't managed to create a new branch yet. But if you've created a new branch, then at the bottom of your GitHub window down here, it should say the name of the current branch that you're on. So I didn't manage to get it working on this VS Code thing, but previously it would have said the word main down here. I think I had that in a previous slide somewhere. Here it says main, for example. If you've successfully created and switched onto a new branch, it will have whatever you named the new branch down here in the bottom left-hand corner. Okay, so what we want to do, just for your reference, in case you want to use the command line, it's the same thing. So what we want to do now is create some new commits on this new branch, swap between the branches, and notice that the commits are there when we're on the new branch. They disappear when we go to the old branch. They return again when we go to the new branch. So to swap between the branches, we can use this, use the same options here in the source control. In the source control button. So have a go at committing some changes to the branch that you're currently on. Have a go at swapping between the branches, and I'll walk around for a second. And this is essentially the main part of the workshop, is understanding how to create these new branches, make some commits on one of them. So I'll give you a few minutes to do that. And please let us know if you're having trouble at this stage too.
Got lost. So once you create this branch.
Yep.
So I might just look at how I have lost in my
I can kind
That's because you're
of kind of close it, but it's telling me that.
No, that's okay.
Yes.
Okay, so
I didn't make an account.
some whole
Are you logged in on?
Here?
Yeah.
Yes, and if you've made no changes on the branch, it's exactly the same.
Yeah.
Yes.
and it's not for one time, so over.
Yeah, so
In that
all
case-
the branches, all the community project.
Changes.
Yep.
Oh, I want to get
so to do that,
We might just need
check out.
to try to might use,
Into
um,
Yeah. Just have you click this button now. And the branches that you have to say swap between the branches.
Okay, so I don't actually have a screenshot of it here, so there won't be an example that you can see. But the easiest way on VS Code to switch between the branches that you have, once you've made a couple of different branches, is to click the name of the branch that you're currently on down in the bottom left-hand corner. And then in the top, you'll see a window comes down and it will list all the different branches that you have, and you can just click on them to swap between branches. So if you're using the command line, the command for swapping between branches is called checkout. And then you check out in the name of the branch. So that's what we're doing here is when I say swapping between branches, the Git word for that is checking out. So check out one of the different branch names. And again, the easiest way to do that in VS Code is to click the name of the branch down here in the bottom left-hand corner, and then choose from the list that pops down which branch you want to jump onto. And as you jump between the branches, you should see the changes that you've made on one branch and on the other come in and disappear and come back as you go back between the branches. And if you want to, you can publish your new branch up onto the GitHub, or not. You can just keep it local. That's also fine.
Yeah, that's one.
So you're right, the branch.
So if you just type in.
If I stay on the branch, you don't do anything if you want to.
So you just need to.
Okay, so that's a good question. Somebody pointed out that if they make some changes in one branch and then swap to another branch, the changes just stay there. If that's the case, that just means you haven't committed those changes. So you just swap in between them, it's not changing the file. So what you need to do when you're on one of the branches, make some changes and remember to commit them, and then they'll be committed to that particular branch. The reason Git works like this is because sometimes this happens all the time. You make some changes and realize that on the wrong branch. So then you're able to check out the branch that you want and then get those changes to the right branch. Yeah. So hopefully now we've made our new branch, we've committed at least one new commit on that branch. We've been able to jump between the old branch and the new branch, see those changes disappear and come back. And if not, please let us know, otherwise we'll quickly go on to just the very last part of the workshop in the next 5 minutes. Okay, so if that is working for everyone, the very final thing that we want to do is merge our two branches back into one. So you can think about this like we've made a new branch in order to make some changes. We weren't sure if these changes were going to work. Now we're very happy with them. We wrote my amazing new change in a text file, and we really like that change. So we want to merge it back into our main version of our repository. The way we do that is by clicking the source control button from the branch that you want to merge into, and you click branch, merge branch, and this will merge whichever branch you choose into the branch that you're currently in. If you want to do that using the command line, the command is git merge and then the name of the branch that you want to merge. And this is mostly just so that you're aware of the terminology. When you go to merge two branches, there are three things that can happen. The first one is the easiest, and that's what will be happening to us right now, and that is called a fast forward merge. And that's what happens when there was changes only to one of the branches that we're trying to merge. And if you imagine the nodes on the graph, all you're doing is straightening the graph out, right? There's no different commits on different branches of the branch, and that's the easiest thing. What's more typical is you do have some changes on both of the branches. If that's the case, in order to merge, you have to create a new commit in order to actually merge those two changes together. That's the sort of typical instance that's called a merge conflict. And this is what happens if you have two changes on two different branches that don't conflict with each other. So like changes to different parts of a file or changes to different files, for example. The third thing that might happen is if you have changes in your two branches that do conflict with each other. That's called a merge conflict. And this is really annoying. When that happens, Git will tell you, hey, I can't merge these two branches. There are conflicts between them. And what it will do is pop up a merge conflict window. And what you will have to do is go through each file that has a conflict and choose yourself how to resolve that conflict. Recommend to avoid this if you can. It's unavoidable in every situation. This is one situation where it's really beneficial to use a text editor like VS Code because it makes this really nice and easy. It shows you a window like this. So for example, in this particular example, I made a change on one version that says this, and I made a change on the other version that says this. I tried to merge them together, and that was a conflict. And so I have to choose which one I want, which is either accept current change, which is the green one, incoming change, the blue one, accept both, which will put them line after the other, or you can also just edit the text and make it say whatever you want. Once you click that button, that will go away. It will stop being a conflict, and then you can continue with the merge. So I recommend not doing that, at least at first, and just trying to at least do a fast forward merge today, and then a regular merge is what happens more often. But give that a go now. Try and merge the changes, synchronize these changes back up to the GitHub, and I'll wander around and see if there are any issues that people have with that. Yeah, probably there was no. Maybe I have to check out the other. If you main, it will merge the file this branch. And you should do that from the other branch. So you can, yeah, it's normally not what happens. So like takes our branch, then merging the branch into the branch and nothing like that. Try it, see what happens. It's not.
You could publish it first before you merge.
Maybe I didn't think so. Nothing. Yeah, nothing happened because you're in the branch and you merge from the same branch into the same branch. So what if I press? Then it will take any changes that you have from main and merge them into your current branch. So try it and see what happens. I can change on this. Yeah. Yes, now it's going to merge from the branch. Exactly. So just to, I'll sort of, that was a question that probably many of you will have. You want to merge, you want to be on the branch you want to merge into. So if you want to merge into your main branch, be on the main branch. Click merge, and then in the top, it'll ask you which you want to merge from, and that's the branch that you want to get the changes from. So that.
Yeah, I know what the question is.
Yeah, I think the price will,
Yeah.
yeah.
So you need to
Save the change.
online.
Yeah.
And then let's do that. Fine.
Yeah. So okay, so I'm gonna make a branch. So I type in branch. Branch is gonna be. Hang on.
You have to name it.
I know.
100, yes.
I should have a main branch up. Okay, because that was my 2.0 branch. So this is main.
I don't know how to do that.
You want to merge 2.0 into the
Yeah. So how
I'm sure there's an
it's your branch, so 2.0 different to
it was. I may have missed all things that
well, if it's, I mean, you want to be careful so you can see the change. Actually.
You don't need to publish it.
How do I?
Go to do some specified side.
Just check out the back. So I think what it is now that it was. So yeah, what you can check out. I don't think you
Yes. Branch.
Save.
Uh-huh.
Oh, I thought you the reason why this is going to is if you have two flags in this here, so you just can't apply flags, but in stage one, you're only connecting one that's probably all.
So it's just saying, hey, are you sure? So
Press With the one thing, 2.0. That's kind of range. This is a main one.
just give me a second. Let's
Pull on push.
Yeah, so just to let everyone know, it's about 5 to 4, so if you've got something else on, you can run off to it. I won't be offended. I'll stick around for a little while if people still want to play around. I'm happy to have a look. But if people are super keen at the end, I've got a couple of extra slides just on some like advanced topics for using Git and GitHub if you're interested. It's something that you can be aware of that it exists and then come back to it a little bit later. So pull request was exactly one of them, so maybe I'll pull up that slide. Okay, so to repeat the question, I was asked, what is a pull request? And a pull request is a GitHub thing. And that just happens to be one of the advanced topics. So a pull request is a very odd phrasing for what I would think of more as a push request. And what this is I've made some changes to somebody else's repository. I think they're really great and that other person should accept those changes. So I submit a pull request, which is requesting that they pull my changes into their repository. So if you want to, you can make some changes on your fork of my repository and then submit a pull request asking me to pull those changes into my version of the repository. So you're welcome to try that out if you want. I'm probably not going to accept them, not because I don't like you, but because if everybody does that, they will all just conflict and your change is probably already conflicted with mine, so that'll be annoying. But at least you can practice doing that pull request. So since I'm on the advanced topics here, the final one I wanted to point out is something which is another just GitHub feature, which is called GitHub Actions. So again, this is not something you really need to worry about at first, but what this is some automated workflow stuff that can happen on GitHub. So it's probably easiest to explain with an example. So this is an example from a repository that I have. And this is a bunch of automatic things that happen every time I push to this repository. So for example, I set up this actions file, and every time I push to this repository, it will automatically attempt to build my code on Linux and Mac and send me an error code if one of those compilations doesn't work, so that I know my code will always compile on every operating system. It will build and deploy automatically documentation for the code and publish it to a web page. It will run a bunch of unit tests and calculate the fraction of my code base that's covered by those unit tests. So it's just a little flavor of some of the kind of neat things that you can do with a Git repository that's stored there on GitHub. Okay, and then the final thing for you just to think about as you head home, if you're really keen, what you can try to do is cause a merge conflict. The best time to come across a merge conflict is in a repository that doesn't matter at all. So the way that you would create one of these is to make changes to the same part of your file on two different branches and then try to merge those branches together. It's very confusing the first time you see it, so I would suggest if this is something that you're interested in learning, to do it a couple of times and figure out what it is actually doing. Yeah. Okay, so I think we'll wrap up the formal part of the discussion here, but again, I'm very happy to stick around here for another 10 or 15 minutes or so, unless other people kick us out of the room. But otherwise, thank you all, and I think I'll stop the recording at this stage as well.